Morning students. In this video we are going to see 10 practice problems for the upcoming TNPSC combined statistical subordinate examinations. Part 10. Question number 1. Two dice are thrown together. The probability that the difference is 1. Option A 12 by 36, option B 13 by 36, option C 14 by 36, option D 10 by 36. When we throw two dice simultaneously, the possible outcomes are 1, 1, 1, 2, 1, 3 up to 6, 6. Total number of possible outcomes equal to 36. Here what is the favorable outcome? The difference should be equal to 1. So what are the favorable outcomes? 1, 2, 2, 1, 2, 3, 3, 2, 3, 4, 4, 3, 4, 5, 5, 4, 6, 5 and 5, 6. So number of favorable outcomes is equal to 10. So probability is equal to 10 by 36. So the correct option is D, 10 by 36. The favorable outcome is the difference should be equal to 1. The first number and second number, when we find the difference, it should be equal to 1. So let us move to the question number 2. Given probability of A is equal to 2 by 3 and probability of B is equal to 3 by 4, probability of A given B is equal to 2 by 3. Then probability of B given A is equal to. So we know the formula of probability of B given A is equal to probability of B intersection A and divided by probability of A. We know very well probability of A intersection B and probability of B intersection A are both equal. So to find probability of B intersection A, what we are going to use, probability of A given B is equal to 2 by 3, that value we are going to use. So probability of A given B formula we know, probability of A intersection B divided by probability of B. So when you cross multiply, what you get, probability of A intersection B is equal to 2 by 3 into probability of B. So probability of B value is given as 3 by 4. So we get probability of A intersection B is equal to 1 by 2. So we need to find probability of B given A, which is equal to probability of B intersection A divided by probability of A. So probability of B intersection A, which is equal to probability of A intersection B, which is equal to 1 by 2 divided by probability of A. What is probability of A? 2 by 3. So probability of B given A is equal to 3 by 4. So the correct answer is option C, 3 by 4. Let us move to the next question. Question number 3. If an unbiased coin is tossed 3 times, what is the probability of getting at least one head? So when we are tossing 3 coins simultaneously, the total number of possible outcomes will be equal to 2 power 3, 8 possible outcomes. So what are the possible outcomes? 8 possible outcomes will be, all 3 can be head, HHH or HTT or THT or TTH or HHT, HTH, THH, TTT. So when we are throwing a die, when you are tossing a coin, the possible outcomes are head and tail. Head can be represented by head and tail can be represented by T. Here we are tossing 3 coins simultaneously. The total number of possible outcomes is 2 power 3, 8 possible outcomes. All the 3 can be head, that we are representing by HHH. Or there may be only one head. For that we are representing by HTT, THT, TTH. Or there may be 2 heads. For that we are having 3 different possible outcomes, HHT, HTH, THH. Or there may be no head, which is all of them may be tail, TTT. So total number of possible outcomes 8. What we need to find, the probability of getting at least one head. There may be one head, there may be 2 head, or there may be all of them may be heads. So one head we are having 3 different favorable outcomes. For 2 heads we are having 3 different favorable outcomes. All of them may be head, only one favorable outcome. So total number of favorable outcome is equal to 7. So probability is equal to 7 by 8. So probability of getting at least one head is equal to 7 by 8. Option D, 7 by 8. Let us move to the next question. Question number 4. If for 2 independent events A and B, probability of A union B given and probability of A is given, then find probability of B. So the basic condition for 2 events, independent events, is probability of A intersection B is equal to probability of A into probability of B. Probability of A is given as 2 by 5. So probability of A intersection B is equal to 2 by 5 into probability of B. So let us consider it as equation 1. So what we need to find probability of B, and probability of A union B is given. So we use addition theorem of probability. Probability of A union B is equal to probability of A plus probability of B minus probability of A intersection B. Probability of A union B value is given. Probability of A we know. Probability of B we are going to find. And probability of A intersection B, what we have found? 2 by 5 into probability of 5. That we are going to substitute in equation 1. So probability of A union B is equal to probability of A plus probability of B minus probability of A intersection B. So we need to find probability of B. So addition theorem of probability, just we are bringing other side. Probability of B is equal to probability of A union B minus probability of A plus probability of A intersection B. Probability of A union B is given as 2 by 3 and probability of A is given as 2 by 5. Instead of probability of A intersection B, we are substituting 2 by 5 probability of B from equation 1. So we are bringing 2 by 5 probability of B into the left hand side, and we take probability of B common, which is equal to probability of B into 1 minus 2 by 5. So take LCM of 3 and 5, we get 15. So 15 divided by 3 is 5, 5 into 2 10, 15 divided by 5 is 3, 3 into 2 6. So probability of B into 1 minus 2 by 5 is equal to 10 minus 6 by 15. So what we get? Probability of B into 3 by 5 is equal to 4 by 15. So probability of B is equal to 4 by 15 into 5 by 3. So probability of B is equal to 4 by 9. So the correct answer is option B, 4 by 9. So first we used the independent events formula. Probability of A intersection B is equal to probability of A into probability of B. Then we have used the addition theorem of probability formula, so that we have found the value. Let us move to the next question. Question number 5. If probability of A is equal to 1 by 2, probability of B is equal to 1 by 3, and probability of A intersection B is equal to 1 by 4, then the value of probability of A dash intersection B is equal to option A 1 by 2, option B 1 by 6, option C 1 by 12, option D 1 by 4. So we need to find probability of A dash intersection B. So straightforward, we are using the formula probability of A dash intersection B is equal to probability of B minus probability of A intersection B. Probability of B is given as 1 by 3, probability of A intersection B is 1 by 4. Just take the LCM. 3 and 4 LCM is 12. 12 divided by 3 is 4. 4 into 1 4. 12 divided by 4 is 3. 3 into 1 3. So the correct answer is 1 by 12. Option C 1 by 12. Let us move to the next question. Question number 6. Probability of the sample space. The probability of the sample space is option A 0, option B 1, option C 1 by 2, option D none of the above. The correct answer is probability of sample space is 1. Sample space is the set of all possible outcomes of a random experiment. So probability of sample space will be equal to 1. So let us move to the next question. Question number 7. If probability of A is equal to 4 by 7 and probability of B is equal to 2 by 3, probability of A union B is equal to 8 by 9, then what is probability of A intersection B? So we are going to use addition theorem of probability. Probability of A union B is equal to probability of A plus probability of B minus probability of A intersection B. We need to find probability of A intersection B. So we bring probability of A intersection B to the left hand side. So we are going to substitute the values. Now we are going to take the LCM of 7, 3 and 9. When we take the LCM of 7, 3 and 9, we get 63. 63 divided by 7, 9. 9 into 4, 36. 63 divided by 3 is 21. 21 into 2, 42. 63 divided by 9 is 7. 7 into 8, 56. So probability of A intersection B is equal to 22 by 63. So the correct option is option C, 22 by 63. So in this problem, just we have used the addition theorem of probability. Probability of A union B is equal to probability of A plus probability of B minus probability of A intersection B. Question number 8. If 2 dice are rolled, what is the probability of getting the sum is neither 6 nor 9? So we need to find neither 6 nor 9. So for to finding that, what we are going to find, probability of neither 6 nor 9 is equal to 1 minus probability of either 6 or 9. So we are interested in finding probability of 6 or 9. So when we are throwing two dices, total number of possible outcomes, that is 6. Getting 6 or 9 we are going to find. The favorable outcomes for getting 6, 1 by 5, 2 by 4, 3 by 3, 3, 3, 4, 4, 2, 5, 1. The favorable outcomes for getting 9, 3, 6, 4, 5, 5, 4, 6, 3. So total number of favorable outcomes is 9 by 36. The favorable outcomes for getting 6 and 9, totally 9 by 36, 6 or 9. So probability of neither 6 nor 9 is equal to 1 minus 9 by 36, which is 27 by 36. So the correct option is option C, 0.75. So for finding probability of neither 6 nor 9, we use 1 minus probability of either 6 or 9. Question number 9. A and B are mutually exclusive events, then option 1, probability of A union B is equal to probability of A into probability of B. Option 2, probability of A union B is equal to addition theorem of probability, second option. Third option, probability of A union B is equal to probability of A plus probability of B. Option 4, probability of A intersection B is equal to probability of A plus probability of B. Here the basic condition is mutually exclusive events. If A and B are mutually exclusive events, then probability of A intersection B is equal to 0. So the correct option is option 3. Probability of A union B is equal to probability of A plus probability of B. Let us move to the last question. Question number 10. A problem in statistics is given to 3 students A, B and C, whose chances of solving it are 1 by 3, 1 by 4 and 1 by 5 respectively. Then the probability that the problem will be solved is option A 4 by 5, option B 2 by 5, option C 3 by 5, option D none of the above. The probability of solving the problems of A, B and C are given. We need to find probability of solving the problem. Problem can be solved either by A or by B or by C. So probability of problem can be solved, can be represented by probability of A union B union C. Problem can be either solved by A or B or C. So P of A is given as 1 by 3. Probability of A solving the problem. Probability of A not solving the problem represented by P of A dash, which is equal to 1 minus P of A. 1 minus 1 by 3, which is 2 by 3. Probability of B solving the problem is given by 1 by 4. Probability of B not solving the problem, P of B dash is equal to 1 minus P of B, which is equal to 1 minus 1 by 4, 3 by 4. Probability of C solving the problem is 1 by 5. Probability of C not solving the problem is 1 minus P of C, which is equal to 1 minus 1 by 5, which is equal to 4 by 5. So what we need to find, probability of solving the problem. Problem can be either solved by A or by B or by C, which is equal to P of A union B union C, which is equal to 1 minus P of A union B union C the whole dash. So by De Morgan's law, P of A union B union C the whole dash is equal to P of A dash intersection B dash intersection C dash. Since they are independent, we are multiplying them. P of A dash into P of B dash into P of C dash. Just we are substituting the value, then we get the answer 3 by 5. So probability of problem can be solved is equal to 3 by 5. Whenever we need to find the probability of solving the problem, we can straightforwardly put 1 minus P of A dash intersection P of A dash into P of B dash into C dash. Well, how many number of events can be there? So here the correct answer is option C, 3 by 5. So in this video, we have seen 10 problems regarding probability. If you like this video, you subscribe my channel and share with your friends. Thank you, students.